Hello class, this is Mr. Joseph and this is a pre-calculus snow day special. Today we're going to be looking at two things. First we're going to finish the last page of section 5.5 and then I'll start you off on the worksheet. That'll be your assignment for today. So on Thursday we looked at the first part of section 5.5, which were these double angle identities that are shown in this box here. The second part on the last page are these half angle formulas that are shown here. We're going to use them, but first we're going to have to earn them. So what number 5 wants us to do is to prove the half angle formula involving sine, that's the first one here, using a double angle formula. So that's what I'm going to do. And I'm going to do all the writing and stuff on this black board here. But what they're telling us to do is we can take one of these double angles identities, and specifically we're going to take the one where cosine 2 theta equals cosine 2 theta. We're going to take 1 minus 2 sine squared theta. This was one of our double angle identities. It told us how to take a double angle 2 theta and write it in terms of a single angle theta. But now we want to do the opposite. Now we want to take a half angle theta over 2 and write it in terms of a single angle theta. So we can kind of accomplish that trick. If let's do it like this. Let's let x be equal to 2 theta. So I'm going to take out my 2 theta in this formula and replace it with an x. So that becomes cosine x equals 1 minus 2 sine squared. And then for theta, since x is 2 theta, if you rearrange that, divide by 2, theta equals x over 2. So this is actually sine squared x over 2. So what that does for me is that takes this double angle formula and writes it in terms of a single angle and then a half angle. And now I want to just solve for sine of this half angle. So I'm going to do a little bit of algebra here. Cosine x minus 1 equals negative 2 sine squared x over 2. I'm going to divide both sides by negative 2. I'm just being kind of lazy here. Divide both sides by negative 2. And then I'm going to switch places. I'm going to put that on the left and this on the right, just for clarity's sake here. So I've got sine squared x over 2 equals, and I'm going to bring this negative here, I'm going to bring that out front. So this is going to be all over 2, but it's going to look like negative in parentheses cosine x minus 1. That negative here is just that negative brought up here out front. We can distribute this negative and make that negative cosine x plus 1 over 2. Okay, which I'm actually going to write. I'm going to erase what we've got here. And I'm going to write negative cosine x plus 1. I'm just going to write that as 1 minus cosine x. Just because that looks a little nicer. And I'm almost there. I've got sine squared x over 2, but I just want sine of x over 2. So I'm going to take the square root of both sides. And when we do that, on the left we've got sine of x over 2. And on the right, when we take the square root of both sides, remember we have to do the plus or minus, so that's what this situation is about. And then we've got 1 minus cosine x over 2. Okay, and that is what's called the half angle formula for sine x. It turns out that sine x over 2 is equal to plus or minus square root of 1 minus cosine x divided by 2. And that's what this first formula is. You can find the other formulas in a similar way. The cosine, you can get it from the double angle formula, just like we got the sine. And then to get the tangent, you can just divide the two. So if you feel like doing that, this is maybe a snowy day. Maybe you got some time on your hands. You can look at that. Okay. But we're going to move on to some examples. So the first example, they want us to do sine of pi over 12. And actually, I'm going to do the second example first because I think it's a little easier to think about. So let's do, I'm going to do example 7, which is tangent of 165. So this is sort of like what we had done in the previous section where we're asked to find evaluate a trig function for an angle like 165 that doesn't show up on the unit circle. So what we were doing before was writing it as a sum or a difference, which we can certainly do with 165, but we're going to do this a different way. We're going to think of 165 degrees as some other angle over 2. We're thinking of 165 as half of some other angle. And you can just figure out what that other angle is that it's half of. You can just do some algebra, multiply both sides by 2. 165 times 2, 320 plus 10, 330. So I can think of this as tangent of 330 degrees divided by 2. Okay, and let me actually highlight this in yellow maybe. That's my angle, 330. That's my theta. Okay. So according to my formula, it's this equals plus or minus root 1 minus cosine theta over 1 plus cosine theta. So this is, I'll do it here. Plus or minus root 1 minus cosine theta over 1 plus cosine theta. My theta, again, is this 330 degrees. So I'm going to go where it says theta. I'm going to erase that, and I'm going to write in 330. Okay. And the common mistake here is that a lot of people mistakenly put in theta as 165. 165 is actually half of what the theta in this formula is referring to. They're referring to 330. Okay. And now it's just a matter of simplifying this. And with a tangent, it's actually kind of hard. Well, not hard, but it's just a little tedious. So let's do it. We've got some room here. Plus or minus square root of 1 minus, and then cosine of 330. We're trying to do these without referring to a unit circle. Let's see, 330, it's like a negative 30 degree angle. The cosine would be the longer one. That's going to be root 3 over 2. So this is 1 minus root 3 over 2 divided by 1 plus root 3 over 2. Okay. And of course we want to simplify this some more. Here we've got basically one. Let me do this. Make this look a little easier. We've got one big fraction bar, and then these fractions within that fraction, and it's all inside of a square root. So it looks kind of crazy, but we'll break it down here. So the 1 minus root 3 over 2, to subtract those fractions, we need to have a common denominator. So I'm going to erase the 1 and replace it with a 2 over 2. Gives me a common denominator, and the same thing here. Erase that 1 and replace it with a 2 over 2. Okay. So that gives me, and now that I have a common denominator, I can actually subtract those fractions. So 2 minus root 3, and that's all over the same denominator of 2. And then big fraction bar 2 plus root 3. That's all over 2 as well. That's just this one. I'm going to make that big fraction bar red again, just so you can see the structure here. Okay. Now we divide the fractions. Divide the fraction. So this fraction divided by that fraction. You can flip the bottom one and multiply, but if you've seen this situation enough, you know these 2's are going to cancel. And what you're left with is square root of 2 minus root 3 over 2 plus root 3. Still kind of ugly. So what we're going to do is we're going to simplify what's inside this bigger square root by multiplying by the conjugate of this denominator so that we get a monomial in this denominator. We get one term instead of 2 things being added. And this is a common trick that we see a lot. So yeah, it should be sort of familiar. I'm going to multiply by 2 minus root 3. 2 minus root 3. And this is all happening within that giant square root. So a lot of layers here. Now when you FOIL the denominators, I'll go below. Why not? I'm going to FOIL the denominators first because I'm excited about the denominators because they're going to actually become one number. So that's going to be 2 times 2 is 4 plus root 3 times 2 minus root 3 times 2. Those middle terms always cancel when I multiply by the conjugate. Then root 3 times negative root 3, that's negative 3, right? Square root of 3 times negative square root of 3 is just negative 3. And that's just 4 minus 3, which is just 1. So actually that whole messiness down here became 1. So that's why I multiplied by that conjugate. That kind of thing always happens, and that's a good thing. So now let's do the top, the numerator. 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. Negative root 3 times 2 is another negative 2 root 3. Negative root 3 times negative root 3 is plus 3. Okay. This is maybe trying your patience right now, but we're almost done. This denominator of 1 doesn't really need to be written there, right? Okay. And then I can see this as 4 plus 3 is 7 minus 4 root 3. It still looks pretty ugly, but that's actually the best we can get it. But the only thing is we have to decide plus or minus, which one do we want? And what we have to do there is go back to figure out what the heck we were doing, and what we were doing was finding the tangent of 165. That's what this is supposed to be. So I'm saying the tangent of 165 actually equals what's down here. Well, we have to decide, do we want positive or negative? Well, if you think about it, you have to, at this point, you have to draw the angle. 165 is in quadrant 2. There's your 165. If this is going to be a tangent of 165, tangent is y over x. The x is a negative, the y is positive. So this is going to be negative. I need to choose a negative. So my final answer would be negative square root 7 minus 4 root 3. And you can put that in, you have a square root inside of a square root. So again, it's kind of ugly. That's the best we can get it. You might want to put that into your calculator and then do tangent of 165 degrees in your calculator and see how they compare. Okay, next example. Sine of pi over 12. equals what? Okay. Again, pi over 12 doesn't, the angle doesn't show up on the unit circle. So if we're going to do this by hand, we could actually use one of those difference identities, or we could use this half angle identity, which is what we're going to use. So I'm going to think of pi over 12 as some other angle divided by 2. And if you just solve for theta, you see my theta is 2 pi over 12, which is pi over 6. If you do a little algebra there, if you want to pause and figure that out, go for it. But your theta is pi over 6. So I'm thinking of this as sine of, I'll do this in a different color like I did the other one. Well, okay. Pi over 6. That's what's being divided by 2. Okay. And according to my formula, and we actually, this is the one we derived, it's plus or minus 1 square root of 1 minus cosine theta over 2. Make sure it's the minus. Yes, that's what I want. Now again, the theta, I'm going to erase where it says theta, and I'm going to replace it with pi over 6, because that's my theta. Okay. And this one's going to be a lot easier than the tangent one. The tangent one's kind of the hardest one to do. Cosine of pi over 6, that's cosine of 30. The y is the short one, the cosine, the x is the long one. 1 minus cosine of pi over 6 is root 3 over 2. Okay, so that became root 3 over 2. Again, we want to add these fractions we've got in this giant denominator here. We want to add these two fractions, so that 1 is going to have to match up with the denominator of the other term, so it's going to have to be, we're going to write that 1 as a 2 over 2. Now that's going to become 2 over 2. Well, I'll just write it like this. 2 minus root 3. And that's all divided by 2. That's what this became. Then there's this giant denominator, and then there's another 2 here. I'm going to make that a 2 over 1 just so we can kind of see that there's a fraction. That's just a little mark there. There's a fraction divided by another fraction, all inside of this giant square root. Okay, plus or minus square root. I'm going to take this fraction and divide by this fraction. So that's going to be 2 minus root 3 over 2. Divided by 2 over 1 is the same thing as times 1 over 2. And let me give myself a little more room. So this, when you multiply those fractions, you get plus or minus square root of 2 minus root 3 over 2 times 2 is 4. And you can simplify that by saying square root of the numerator, which is this, over square root of the denominator, square root of 4. Square root of 4, I can more simply write as 2. And that's basically my answer, but now I need to, again, choose between positive or negative. Well, pi over 12 is half of pi over 6. It's a very small angle that's in the first quadrant. There's your pi over 12. So if it's first quadrant, the sign is going to be positive. So final answer here, you want to choose positive. You don't have to write the positive, of course. You can just write 2 minus root 3. Oh, you know what? That square root sign just belongs on the numerator all over 2. That is the sine of pi over 12. So your answers are going to look kind of ugly like this. That's okay. But you can compare that again in your calculator. I encourage you to do that. Okay.